So in today's lesson, we are going to draw Lewis structures for ionic compounds. So let's start. We know that ionic compounds are made up of ions, and they are formed by cations and anions, where electrons have either been lost or gained. So let's look at nitrogen. The electron configuration for nitrogen is 1s2, 2s2, 2p4, 2p3, where it has 3 plus 2 is 5 valence electrons. So to draw a Lewis structure for nitrogen, I'm going to just write N. Now this N is going to include all of the inner electrons plus the nucleus, which contains the protons and the neutrons. The valence electrons, I'm going to draw on the outside. I have 5 valence electrons. So here's what nitrogen would look like. All right, a simplified version of nitrogen. This N is the protons, neutrons, and any inner electrons. Just the valence, those outer electrons go on the outside. Now, we've already learned that nitrogen gains 3 electrons to form nitride. So if nitrogen gains 3 electrons, what is going to be the Lewis structure of nitride? If it starts with 5 and it gains 3, it now has 1, 2, 3 plus the 5, so it has 8 total electrons. We are going to put that in a bracket with a 3 minus as a superscript. Let's look at magnesium. Magnesium, to draw magnesium, it loses 2 electrons let me start over. I got ahead of myself. Magnesium has 2 valence electrons. So here's what magnesium would look like. Now, in its cation form, if magnesium loses 2 electrons, it has no more electrons, so we just put it in brackets and a 2 plus as a superscript. Now, this is going to be important if we wanted to draw a Lewis structure for a compound. So let's look at magnesium fluoride. If we were to draw the magnesium fluoride as a particle diagram, we have 1 magnesium, which is a 2 plus, and 2 fluorides, each which are a minus. And now you'll notice I have the fluorides opposite each other. I would not want to draw something that looked like this, where I have 2 negatives together, because we know like charges do what? Like charges repel. So this is not a good structure because like charges repel. So magnesium fluoride is never going to look like that. We're going to have the positive in the center attracting 2 different fluorides on opposite ends. So if we were to draw this as our dot structure, our Lewis structure, we've already drawn magnesium above. And then I have 2 fluoride ions. Each fluoride gains 1 electron to give me 8 total valence electrons, and it's got a -1, and I have 2 of them. All right, so here is my dot structure. Now, it's important to note that ionic compounds are going to form a crystal lattice, which is a square-like structure and it is formed by salts. And we know that salts are ionic compounds. Any ionic compound we call a salt. All right, so a crystal lattice is a square-like structure, and it is a 3D concept. So let's look at the crystal lattice of, let's say, sodium chloride, NaCl. This is table salt, the salt that you eat. All right, so sodium is a Na+, and it is attracted to a chloride, which is attracted to a sodium, which is attracted to a chloride, which is attracted to a sodium, which is attracted to another. We got a sodium here, there'll be a chloride here, okay? And what we end up forming is this 3D structure where we have positive attracted to negatives, negatives attracted to positives.